Welcome to my workbench. Today I wanted to talk about a stereo transistorized amplifier that I put together a couple years back. My goal was to try to retain some of the vintage sound that was back in the late 70s when they made all those high-powered receivers and such. On this one I actually have some old components that I've taken and along with some new components created something that I think sounds nice, and let's take a look at it and we'll discuss it a little more in detail. The idea for this amplifier first started some years ago. I think at around 2010 someone gave me an old realistic STA 2290 receiver that was pretty damaged. It was pretty beat up. That was manufactured in about I think around the late 70s, early 80s, and it retailed for around $600. And it was a nice unit, had a lot of features, but it had been beat up. I don't know what happened. Someone destroyed some of the PC boards, and it really, it was beyond repair. I don't think I could have never found all the parts without buying another whole unit and possibly making two from one. So I scavenged it for parts, and within it there was a nice output transistor array that contained some vintage 70s Sanken output transistors. There was a 2SA 1215s and the 2SC 2921s arranged in push-pull outputs on that, and on a nice heat sink. So I had it sitting on a shelf for a couple of years when thinking what to do about that. What could I do to make something of it? And this is what came of it. This was built on a standard Hammond chassis with a cover, and I incorporated a volume balance and bass, mid-range and treble preamp in there, and it puts out approximately close to 200 watts, about 100 watts a channel. And I use it outside. I have a bigger set of old realistic Mach 2 speakers that I came across with, I think they have 15-inch woofers. They're three ways, and I've used it a few times outside. I really crank it up on a few parties we had out in the backyard, and it really sounds nice. A little bit too much power for me inside the house, but it was a nice project. And the first thing I need to do is I wanted to find a nice driver setup. And I use the driver board that from Elliott Sound, one of the boards that he created. His it was a Project P3A hi-fi power amplifier PC board that I used, and also I incorporated his P33 loudspeaker protection board in there also, and it turned out did a really nice job. And as I said, it sounds good. So before we open it up and tear into it, and just to show you what I did, let's look at the schematic close up and I'll go over that a little bit. Before I zoom in on this a little bit and talk about it, I wanted to point out two things. I didn't incorporate the schematic for Rod Elliott's driver board and also his loudspeaker protection board. I'll leave the links down in the description where you can check it out and read about those items. And also the links that are on the schematic for those two items are not correct. He has upgraded and the links are a little different now. So let's look at the power supply first. Let's zoom in and we'll go to the top. And let me move this down here, and we'll talk about the AC input. I wanted a little bit of delay on the startup on this. If everybody realizes, if you don't, you get the thunk as the caps charge on the power supply and such. So I have a little delay circuit I added there. As you can see, in series with the primary of the transformer, there is this area here. And what it entails, there's a relay, and there's three 68 ohm resistors, 5-watt resistors in series with the primary of the transformer. So when you first energize the power to the transformer, you're getting a lower voltage delay through these power resistors. And when the output of the power supply reaches 33 volts, this relay will energize, and then it'll bypass these resistors. So we'll get full voltage off the primary of this transformer. So in this, we have, a good power supply is always the first part of any amplifier. You really need to make sure you have a nice, clean power supply with a lot of reserve capacity. And this is a dual rail supply. Now, Rod suggested no more than 35 volts plus or minus on the rails on this. But I used, because these output transistors I use can run up to 160 volts maximum, I used 49, ended up with 49 volts minus, 49 volts plus. So that's about between plus and minus. You're looking at around 100 volts total here across the two. But I used two 25 amp rectifiers for each. There's two secondaries. Now this is a this is an Anatech toroidal transformer here that I used. I'll show you when we open it up. And it the output has 235 volt 5.7 amp and 215 volt 2 amp outputs on it. So what we're ending up here through the power supply, again, we're ended up with the VCC is plus 49 and minus 49. And also this affair here is a grounding scheme. I'm using a lot of my amplifiers to help cut down the hum or any ground loops available. You can see you have the chassis ground and you have the audio ground. Well, what happens in this, if you see there's a bridge rectifier here, and these 2 points here are tied together, then you have a 10 ohm resistor, and you have a capacitor there, and then goes out to your chassis ground. Well, what that does is, if you have any ground loops, you kind of have a 10 ohm resistance between audio ground and chassis ground, and this capacitor will shunt any high frequency interference that you may have directly to ground. So as far as the circuit sees for any high frequency interference, it's a direct ground to the chassis ground, which of course is connected to the ground on your power supply. And if you did have a short anywhere to ground, of course these diodes will conduct, a diode will conduct at 0.6 volts. So anything over that, you have a conduction and you'll blow your line fuse. So it's kind of a little bit of a protection there. So let's move down to the preamp power supply. The same setup. You have the bridge rectifier, and we have a plus and a minus 12 volt regulator there to provide our plus 12 volt and the minus 12 volt to the preamp tone. And the preamp tone is just an op-amp circuit with treble, mid, and bass. I use some OPA 2604 op-amp in there, and you have the treble, mid, bass controls in there, and then of course there's the input, and then the output goes to your amplifier. Now let's look at this is where the driver board sets in, and these Sanken output transistor modules, they're pretty beefy guys on that heatsink. I'll show you that when we open it up. And that worked out real nice. So I was able to mount Rod's board right to that heatsink. And the output of the speakers go through his protection board. And you have a couple relays. I'll show you that when I add it in. So if you do have any issues, that will automatically disconnect the speakers and actually shunt the speakers themselves to ground to protect them from anything if happens inside the amplifier. And this output array that was in the original realistic stereo had a high temperature sensor on it in case that heatsink overheated, and that will shut down and automatically disconnect the speakers if it gets too hot. So I'll put a link also to this schematic where you can actually download it and have a better look at it, what I did. But the power supply board, I used a board that I had made for this, and it worked out well. We'll show you that when we open it up inside. So let's move on and let me open the cover, and then we'll take a peek inside. Okay, we have the top cover off, and on the front you can see this nice output transistor array that was in the original stereo. Here is Rod's driver board that I mounted on the back of it. Let's spin this guy around. You can see it mounted nicely on the back of the transistor array. I don't know if you can see those, well, you can see the green boards down in here. You really can't see the, because they're mounted to the heatsink. They're actually way down in there. There's one, there's the other back of the board that the output transistor are, both of them are mounted on for both channels, left and right. Of course, we had added some heat sinks here on Rod's board, and this, you can see the transformer there, and our power supply board here, and I just threw a couple heat sinks on top of those rectifiers. I don't think I need them, but I put them on there anyway. And I basically can see what it looks like inside there. Now I'll pop the bottom. I'll show you where I put the relays and how I mounted everything. But all in all, it turned out to a nice job. Let me pop the bottom off and we'll have a look in there. Looking at it from underneath, we'll start over where the power feed comes in. This is that relay for the power on delay. This is a nice heavy 20 amp relay that I put in there. And here are the 3 resistors for that time delay setup. And look, this is the preamp board. Of course, with your inputs there. These are the 2 relays for the speaker protection Those are 12 volt Potter and Brumfield K10P 11D 15-12s I used. And this is Rod Elliott speaker protection board here, which is operating these relays. And this, of course, this whole setup, this is all part of the speaker protection, this area here. And here is that grounding affair that I used with the rectifier, the 5 watt 10 ohm resistor, and the cap. So it all worked out nice, and that's about it. And if you have any questions, I'll leave some more information down in the description, and with some links to Rod Elliott's site and the boards. He has some nice articles there, a lot of good information on audio there, and a lot of things that he has done, and he provides boards for a lot of his projects. If you'd like to check into it, and you might find something interesting. So until next time, we'll talk about something else. See you later. Have a good day.